Hi super scientists, my name is Mr. Mohammed and I am a science teacher at Upper Batley High School. Today you are going to be investigating how air resistance is affected by surface area. Now, have you ever been in a car whilst it's travelling and then ended up sticking your hand out of the window like this? What you will find is that your hand ends up getting pushed back. Sometimes you may have been a little bit mischievous and ended up placing your hand like this and noticed that your hand is just waving up and down or is just staying in one place. Now, have you ever wondered why that is? Well, it's all to do with all the air particles that are around us causing air resistance against our hands. Now, what do I mean by particles? Now, all around us, and even when we're breathing in, we are breathing in these tiny little things that we can't see called particles. Now, they are hydrogen particles, oxygen particles. When we're breathing out, we are breathing out carbon dioxide particles. So when we place our hand out of the window like this, all of these particles are hitting our hand and pushing our hand back. When you place your hand like this, all of those particles are only hitting a certain area, which is why it doesn't push your hand back. Now, you are going to be investigating this air resistance, but you are not going to be placing your hand out of the window. What you are going to be using are these, what we call parachutes. Now, you are going to make these parachutes yourselves, but you are not only going to make one parachute. You are going to make two different parachutes, one being of a larger size and a slightly smaller one. What you will then end up doing is that you are going to drop these parachutes and you are going to investigate how air resistance is affecting a large parachute and how air resistance is affecting a smaller parachute. Okay. Now I will demonstrate what you are going to do. You're going to need a meter rule stick. You are going to need a stop clock. And you are going to need two parachutes of two different sizes. Okay. You can use one that's quite small like this, about 15 centimeter by 15 centimeters. And then you are going to make a slightly larger one, 25 centimeters by 25 centimeters. Up in each corner of the parachute, you are going to place a little hold, or you can use some sticky tape, and you're going to attach a string to it, and you are then also going to attach one paper clip at the end of that string. You will do the same thing on each of the four corners of the parachute, and then using it, and then with the help of a partner, you are going to place the parachute on the end of a meter rule stick, and then you are going to take it to the ceiling and then drop it. Now, before we end up dropping the parachute, what do we need to do first? Okay. Now, you may have figured out that we need to start the timer first, otherwise we are not going to know how long it takes for it to reach the floor. Okay. So one person will end up moving the ruler away from the parachute. The second person will end up pressing the start on the stop clock. Okay. Unfortunately, I don't have any partners or any helpers over here, so I'm going to have to do this all by myself. Okay. So when I press the green button, I'm going to start the stop clock, and when I press it again, it's going to stop. And then I stopped it. Okay. Now you are going to do this 3 times for one size parachute. So for example, the 15 by 15 centimeter one, I'm going to do this 3 times, and then I'm going to take an average. Now your class teacher will explain to you how to take an average. Okay. Then you will repeat the same experiment with a smaller parachute. Okay, this is one that I made earlier. And again, you will drop this. You will drop it once, time it how long it takes for the paper clip to touch the floor. Do it the second time and time it again how long it takes for the paper clip to touch the floor. Do it the third time, time it how long it takes for the paper clip to touch the floor, and then take an average. By taking an average, you will eliminate any errors that you may have made, and you will make your results a lot more accurate. Once you have done this, you'll be able to decide which parachute ended up taking longer to touch the floor. And at the end of this, and then when we end up doing all of this experiment, we'll be able to explain why it may have taken one longer to touch the floor than the other, or maybe you'll find something different. Have fun. Welcome back, super scientists, and I'm hoping that you had fun during that practical. And I'm also hoping that you got some fantastic results while you were having fun during that practical. Now, what you should have found is that the larger parachute ended up taking a lot longer to touch the floor, or a lot longer to land, than the smaller parachute. And do you know why that is? Well, it's all to do with air resistance and surface area. You see, the larger parachute has a larger surface area. Therefore, when it's falling through the air, there are more air particles that are hitting against this parachute while it's falling through. Therefore, there is more air resistance. If there is more air resistance, this object is going to be moving through the air a lot slower compared to a smaller object. Okay, because this one has less surface area, there is going to be less air resistance as it's falling through the air. Therefore, it's going to move faster. Now, could you apply what I've just told you to how our hands end up moving back when we're traveling in a car, when we place our hands like this compared to this? Now, it's all to do with the surface area. How are you increasing the surface area when you've got your hand out of the window? When you've got it like this, there are more particles being able to hit your hand compared to when you've got your hand like this. Okay, which is why it ends up pushing your hand back. Now, you can do this at home in a variety of different ways. You can use an even larger parachute and see how it's affected. And you should already be able to predict what's going to happen if I use an even larger parachute. Or maybe I don't want to change the size of the parachute. Instead, I want to change the mass at the end of the parachute. So keep the parachute size the same and attach one paper clip and time how long it takes. Attach a second paper clip and again time how long it takes to drop the same height. Okay, and your teacher could talk to you about control independent and dependent variables as well. Okay, you can use different fabrics or you can use different materials for your parachute. Instead of using a black bag, you can maybe use some fabric. Okay, or maybe you can use a white carrier bag. Okay. And if you really want to go for it, what you can also do is get your teacher to boil an egg for you, and you can do what we call the egg drop test, where you're going to boil with a boiled egg. You're going to try getting it to have the most amount of air resistance to stop it from cracking when it reaches the floor. Okay, maybe that could be a competition for you guys to do towards the end of the year. I hope you had fun and thank you for watching.